The dataset for the error predictor consists of instances used to train the original model. It also includes the newly created error features like blurriness score or sentence length, and a binary label indicating whether the original model correctly classified each instance. A value of 0 indicates a correct classification and a value of 1 indicates an incorrect classification. Selecting the appropriate Bayesian model for predicting errors. Options include Bayesian logistic regression, Bayesian neural networks, and Gaussian process classifiers. The choice depends on the complexity and nature of relationships between error features and errors. Assign prior distributions to the parameters of the Bayesian model. These priors represent initial beliefs about the importance of error features before observing the data. A weakly informative prior may be assigned, reflecting an initial assumption that no single feature is overwhelmingly important. Training the Bayesian model using the prepared dataset. This involves inferring the posterior distribution over the model's parameters, given the data and the priors. Markov chain Monte Carlo, abbreviated as MCMC, methods, e.g., Hamiltonian Monte Carlo, are often used for inference in Bayesian models. The trained Bayesian error predictor outputs a probability that the original model will make an error on each instance. This probability reflects the model's confidence in its prediction of error based on instance features and prior beliefs. Bayesian logistic regression, a common choice for binary classification where the error label is the target variable. The weights have prior distributions. Bayesian neural network. This provides uncertainty estimation, which is useful in error prediction to quantify the confidence in predictions of errors. Gaussian process classifier. A good choice particularly when dealing with complex relationships between error features and errors made by the original model. Analyzing the posterior distribution of the Bayesian error predictor's parameters. This reveals which error features are most strongly associated with the original model's mistakes. Error features are computable characteristics of the input data designed to capture patterns in the original model's errors, like a blurriness score for images or sentence length for text. Binary labels indicating whether the baseline model made a correct prediction, denoted by O, or an incorrect prediction, denoted by 1. The instances used to train the error predictor are the same as those used to train the original model. This ensures the error predictor learns to identify errors on data the original model is familiar with. The Bayesian error predictor outputs a probability for each instance, representing the likelihood of the original model making an error. This probability quantifies the confidence in predicting the original model's mistakes. Combining the original model training data, the computed error features, and the binary error labels to create a dataset specifically for training the error predictor. This combines both the data and identified weaknesses.